Hello, everyone. A very good afternoon. I would like to thank you all for joining with us today. My name is Aparna, and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. Payatu is a research-powered cybersecurity consulting firm. We have a decade-long track record with a singular focus on cybersecurity. The foundation of Payatu rests upon three pillars: community and conferences, consulting and training, and products. Community and conferences encompasses NICON, an international security conference, training, and exhibition platform. Hardware.io is a hardware security focused conference along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen network infrastructure. Lastly, we have core offerings: IoT Auditor, an IoT security testing and compliance platform; Exploity, an open source IoT security testing framework; Exploity Academy, a comprehensive online learning platform that empowers professionals with the knowledge and skills to excel in the field of cybersecurity, particularly in the context of securing IoT devices. Currently, this academy is running the 4th of July sale. So people who are interested in learning IoT security can go and take advantage of this sale and learn from the best in IoT security. CloudFuzz. CloudFuzz is an automated and highly scalable fuzz testing platform. Here is an overview of the various consulting assessments we are known for across the globe. Payatu has delivered many cyber talks and workshops in top security conferences that also include Black Hat and DEFCON. We take pride in the decade-long impact we have created by contributing to the cybersecurity community all around the world. As part of our ongoing commitment to fostering knowledge sharing and collaboration in the cybersecurity realm, Payatu has launched an exciting initiative, the Payatu WhatsApp community. The community aims to educate various organizations with industry-specific cybersecurity content. For those curious about Payatu hirings, I would like to call upon Akanksha, our HR head, who would shed some light around it. Akanksha?
Thanks, Aparna. Hello, everyone. Welcome to the webinar. I am HR from Payatu. A couple of you have been connecting with me over LinkedIn to understand the openings in Payatu. So here is the time, and we have these vacancies over here. So we have opening for source code review, red team, network and infrastructure, Android or iOS, and cloud security. So you can assume that around 4 to 5 openings per role that we have right now. So grab the opportunity, and you can also spread the words among your community. People are looking out for change. Do refer to them. You can visit our career page. You can apply from there, or you can visit our LinkedIn page and you can apply from there. So yes, over to you, Aparna. Thank you, everyone. Just connect with me over LinkedIn, and I can share the email ID of the concerned recruiter who is looking out for these roles, or you can directly apply from the page. Thank you.
Thank you, Akanksha. So, guys, that was all about Payatu. Today, Amit, our associate security consultant, will deliver a webinar on how to get started with Android malware analysis. You can read all about him on this slide. Before I hand it over to him, I request you all to follow a few housekeeping tips. Please be on mute. If you have a question, you write it in the chat box. We'll answer that at the end of the webinar. We will be releasing the recording of this webinar soon on our digital channel. So make sure you're following Payatu. If you're not following Payatu, please check the links provided in the chat box to find Payatu's digital channels. Without further ado, let's get started. Amit, over to you.
Thanks, Aparna. Let me know once my screen is visible.
Sure, Amit. Yes, your screen is visible.
Thank you. So good afternoon, everyone. I'm Amit Srivastava, and today we are diving into the topic of Android malware analysis. We will focus to understand what is a malware, how it is different from a legitimate app that we download from Play Store, and how we can identify if an application that we have installed in our system is a malware or not. I'll try to keep this whole webinar to be as basic as possible so that if anyone is a beginner, they won't be having troubles. But if you are having experience of Android penetration testing or Android development, you will be having an edge in understanding how malwares work and how they are different from our legitimate applications. So this webinar is divided into 6 sections. The introduction part, where we'll look what is a Android malware, why they are being crafted, and what all device and what is the overall landscape of Android malware. Then we'll look into the basics of Android. The third part will be what is targeted components of a malware, how they propagate, and various different type of malware that we have observed over the years. The fourth and fifth part will be looking into the various tools that we can use to understand or analyze malware, their activities, and what they all want to do. And the fifth part will be examining two or looking into the source code of two malwares and understand how they were working and what impact it would have done. And at the end, it would be conclusion. Moving forward. So what is a malware? There is a very thin line difference between legitimate apps that we install from various type of Play Store or we develop and install in our system and the malware that we get in our system. Uh, it's all dependent on the intent, what an application is doing and what a malware is doing. Malware are like those sneaky guests we have in our functions who are just there to ruin our party function and steal our snacks, maybe use our resources without our permission, and etc. What malware is doing is they get installed in our system, look into our SMS, maybe contacts, stole our resources. For example, if there is a crypto malware, it will get installed on our system and use our CPU power for crypto mining and etc. Even it can be used for DDoS attack. Let's take an example of a malware and a legitimate application. We all use WhatsApp, and we have seen that we are having WhatsApp for our desktop or for our laptop. And the process to connect our WhatsApp with our desktop is we have to install the desktop application. And when we launch it, we need to scan a QR code with our mobile application. And then all of our data is installed in or is downloaded to our desktop, and we are able to use it for chatting and various kind of things. But what if I tell you there's a way in which it is a malware, it will connect a attacker's desktop with your Android application. It means that an attacker would be able to see what all chats, messages, and video you are sharing. So this is a very thin line difference between a legitimate app and a malware. It's all about the intention of the application. What is the motive behind crafting the malware? Why do people even craft malware? The very biggest motive is financial gains, information theft, surveillance, or even just causing chaos, or to have some kind of resource which they don't own but they're able to use. For financial gains, they are.
Amit,
Yes.
your voice is a little muffled. Can you be a little more, like, let me
Hello.
check the mic?
Okay. Is it clear now?
Yeah, it's clear.
Okay. Thank you. So let's continue. Financial gains. So many malware authors create adwares or maybe trojans like Joker application or various other kind of malware, which they use to steal our credit card credentials. Maybe, for example, BlackRock was recently found, which was stealing our credit card credentials and pins, even our OTP, what we receive. Let's suppose if we have installed a malware in our system and an attacker is making purchase against you, and they will be having our credentials of credit card, maybe debit card, and they purchase something from Amazon, will be receiving OTP from that. And that OTP is received by the attacker and they can use that. In this way, they will be generating funds, or if they have created an adware, it will be running in the background and just clicking on random pages which malware author or the attacker have crafted, integrated with Google AdSense. And multiple clicks on Google AdSense will increase their ad clicks and hence generate revenue. If we talk about surveillance, recently in the Russia-Ukraine war, have noticed that there were many malwares were created and shipped using various channels, using Telegram or another websites, stating that it will be helping Ukrainian people to get some food or shelter or locate where are the safe houses. But at the back end, what they were doing is sending their exact location, their audio files, even clicking some pictures of their surrounding and sending it to Russian military, which they used against them. If we talk about resource hijacking, a malware can be installed in your system that will run in the background and use your computation power for crypto mining. And in this way, an attacker is not investing in hardware devices, but still able to mine some cryptocurrency and making some profits. Moving to the next part, what is the landscape for Android malware attacks? Like what all places Android malware can be detected or they can attack? In the very first look, we can just think of maybe our smartphone or tablets, but actually it's way bigger than our thought. Malwares can attack our smartphones, smartwatches, smart TVs, smart home devices, our CarPlay, Chrome OS, even IoT device. You can see all the various kind of malware I have listed. These were using various kind of techniques to get our Google credentials or our uh, credit card information, even recording our using microphones. Or if we'll talk about the brick bot, what it did was it created a botnet attack that can be used for DDoS attack across many platforms. And when they think that the device is not working properly or they just don't want that device, they will just break that IoT device. It means that we won't be able to use these devices. Specifically talking about the VR agent, that is for smartwatches, we haven't encountered any malware in the market that is directly attacking our smartwatches. But this was a POC malware created just to demonstrate that malware could be there that can attack our smartwatches. Moving to the next point, the Android architecture. We all know that the Android is based on the modified Linux kernel, and this kernel forms the core of Android architecture, providing essential functionality like memory management, hardware drivers, and security mechanism. The next layer is of hardware abstraction layer. It is a crucial interface between Android framework and the device hardware component. It standardizes communication methods, allowing Android to interact seamlessly with various hardware configuration across different devices. By abstracting hardware-specific details, it enables developers to write device-agnostic code, simplifying the app development and ensuring the capabilities. The next layer would be combination of native libraries and Android runtime. If we are talking about native libraries, these are the pre-compiled libraries written in C or C++. They provide critical functionality such as multimedia processing via libraries like OpenGL for graphics and uh, FMMPEGs for video, audio, web rendering, and low-level system operation. For that, we can use native libraries. The Android runtime. It is the managed runtime environment in Android responsible for executing and managing application code. It is the replacement for older Dalvik runtime. It replace the advancement made in ART was that it uses ahead of time compilation, which translate the app's bytecode into native machine code during the installation, reduce runtime overall, and improve our app's performance. And together, this native library and art forms the backbone of Android execution environment. The next layer is of Java API framework that helps developer to connect with various features like multimedia handling, storage, and connectivity. And using these, developers can develop their application. And the last one is of system application. They are just the pre-installed application we get with our phones when we purchase it. Moving further, to know Android application components, it's important because when we'll be analyzing a malware, we'll be looking into various activities, even broadcast receivers, and how they are used to execute something malicious that is not noticed by a normal user. So, what are activities? They are like different pages on a screen. For example, if we talk about a messaging app, when we open a messaging app, there is list of our communication or chats we have, and there's a setting option. So there are two different pages that is visible to us. These are two different activities. If we talk about service, they are the tasks that are being performed in the background without needing user interaction. For example, if we talk about Spotify, even we are playing some song, and if even we turn off our screen, the songs keep on playing. That means the application is running in the background. If we talk about a broadcast receiver listens for system-wide broadcast announcement or message. They are like listener that trigger action. When something happens, for example, a SMS message is received, they will trigger some action like a pop-up that will show user how what message is received. If we'll consider this broadcast receiver in terms of malware, malware author can write something like if a SMS is received, then send that SMS to some particular domain that is embedded in the application or it is connecting with its C2C server. Content provider. They manage access to structured data. They allow app to securely share data over the apps or access system data like calendar events, contacts, media files, etc. So these are the various components that are present in the Android application. If we look into the application structure, it's mainly consists of lib resources, SS classes, Android manifest, meta, and resources. The library folder contains our native code. If we'll download a Android application, decompile it, and look into the library, if there are native code written in those applications, we can find something called lib.so. These files are the native code of our application. In resources that contain a predefined folder uh, that is supported screen orientation and OS version. Assets resource is the folder hierarchy controlled by developer. They put all their assets over there. Class.dex, it's a Google's proprietary format for their version of Java VM. In Android manifest file, it is like a index of our application. In this, we can see all the permissions that an application is asking for, and each and every activity services they have defined. Meta, that folder just contains verification information that is created while we sign our application. And resources contain information linked to the code like classes.dex. Moving on, how application and Android application works. So we are aware that Android was secure by design. It means that all the application are not just installed in our disk and everything is accessible by every application, or anyone can get information from another application. There is a ideology of sandboxing. It means that every application is sandbox. They are separated from another application, and if they want to share something, they can use various kind of receivers and broadcasters. So if we talk about the how an application works, is the application folder is there in our system, and when we launch the application, all the requirements is loaded into our memory, and then it's get executed, and by this way we are able to use our application. And when we close our application, not just move it to the background, but properly close it, all those resources that are loaded in the memory are removed from the memory. And this is an interesting part where some malwares can use this feature of loading. We'll discuss it later. It's called dynamic loading. Like an DEX file or some malicious code will be loaded by the application when it's getting into our memory. And once everything is getting closed, it will remove that from memory, and it would be untraceable by any software or antivirus we are using, until and unless we specifically look for it or we check our memory. Now we have learned about the various components. What are the targeted components by a malware? The most abused component of an application is permissions. If we uh, if we talk about the application permissions, an application want to run anything or do anything, they need our permission. If application want to access our camera or contacts, they have to define what they want and how it is what they want to do actually. So one of the permission is accessibility permission. If that permission is given to an application, it is having a complete control of our system. It is able it would be able to do anything with our system, like give permission to itself or any function that a normal user would be doing. We have learned about the activities, how that activities can be exploited. The activity can be exploited. Let's suppose a malicious app create an overlay activity that gets overlaid on another applications, and we are forced to click on that. This activity component or pop-up component can be used by ransomwares. Then web view can be exploited to load malicious website or execute malicious JavaScript to steal our credentials. Also, native codes are exploited nowadays in various malware. If we'll observe, many authors have started writing their proprietary or malicious code in native code, that is the lib.so file, so that it is untraceable by normal scanning or anything. Moving further, methods of propagation. The very basic or simple answer for how an malicious application can get into our system is human error. And if we are able to eliminate that human error element from the whole scenario, there won't be a real need for malware analysis and security. But I don't believe it's possible. So the second biggest method is phishing or social engineering. Phishing emails could be sent, what do we mean by social engineering? We are aware about the Uyghurs Muslim in China. They are facing various kind of difficulties. So what malware authors can do, they would be creating some application that promise to provide them food or shelter, but those malware would extract their location and or maybe click their pictures and send those to government, and that can be used against them. Third party app stores. There are people who think they just don't want Google Play Store or authentic application store. They can download application from anywhere, they will trust it. And mostly this happen using social engineering tricks again. Let's suppose there's a new web series that you really want to see. You'll get an application that is promising that it will show all those web series on different platform for free. Now you download that application and it will start exploiting your system by taking your SMS screenshots, your contacts, and etc. Various other methods used are app repackaging, self-propagation, dynamic code loading that we discussed, that application will load some piece of malicious code while it's getting loaded, or installing by another app. Many malicious application have potential to install various other or smaller apps from their C2C server and start getting it executed using dynamic manifest file or polymorphism. In that, malware authors are rapidly changing their uh, code of their source code so that it is still undetected by various systems. How do malware hides? If we'll talk how they stay in our system, there may be various different method like using inscription, obfuscation, or dynamic code loading, so that is not able to verify that it's a malware or not, if they are doing something malicious or not, by stealthy installation or polymorphism maybe, or using smaller steps. It's called anti-evasion techniques. They can use anti-evasion techniques, uh, executing small part of the whole bigger process so that user won't detect. In this way they'll be bypassing our behavioral analysis. So or many application have capability to hide their icon, so it won't be visible to us, and user won't think that there is no malware in their system, and we won't be able to detect or trace them until unless we are specifically looking for it. So let me show you one of example. This is a Bitcoin wallet application that when on installed in our system will ask for our accessibility permissions. And let's suppose we are not aware of these things and we give accessibility permission to this. What will happen? We have provided it with accessibility permissions, and now you can observe it will provide all various kind of access to itself. As it is having that one accessibility service, we don't need to manually click. Everything is automated. Okay, now we don't want it. We'll just install it. But if we'll see that Bitcoin wallet is gone and everything seems to be good, there is just a Gmail. See, it's changed. If we'll delete that application, it's not actually getting deleted, but just repackaging itself or changing its icon. It's changing it to YouTube right now. But we can see we having our original YouTube over there, and this is another YouTube. Same. If I'll try to uninstall it, it will again change to Gmail. And now even if I want to go to settings and remove it accessibility permission, I won't be able to do that because it will be stopping me. The only way till now I have discovered to remove this type of application is moving to the safe mode, and then we can just uninstall it. There may be various other launchers that might assist you to do so, but normally this is the scenario. Okay, so we have seen in these are the various methods by which malicious application get propagated and stay in our device. Now, if we'll talk about various type of malwares, there are adwares that will aggressively display unwanted advertisement and just try to uh, or force user to click on them. That might install some another malicious application, or it will generate some funds for the attacker. There are ransomware.
Amit,
Ransomware, what they
can
does
you,
is, hello,
Amit, can you turn on the presentation?
is it not visible?
Uh, in the bottom, where the Zoom part is, right? Bottom right
Yes,
of your
yes.
presentation. Okay.
Is
Exactly
it visible?
120%.
Okay. Is it clear and visible, right?
Yes. Just turn on the presentation. It will increase the visibility.
Okay, you want me to go into slideshow mode? Better now? Okay. So we have talked about ransomware. What they do is they lock our screen and force us to pay some amount of money to them. Then we have banking trojans, spywares, SMS trojans, or rootkit malwares. All they want to do is to steal our information, SMS in one or the either way. Uh, Moving to the next part, the static analysis part. For this, we use normally JDAX or a tool like MOBSF. What that does is our application is packed in DEX format, and JDAX decompile those DEX, and we are able to view those source code of the application. And MOBSF is a static tool that will list out our permissions and various other things. Uh, that in a good way that is presented, it will mark all the networks, certificates, uh, services or broadcast that is active. If we want to decompile the application using another tool, APK tool is there, we can use that. And there are various other tools for static analysis. Our main goal is we want to look into the source code of the application we are having. Moving to the next part, uh, unpacking the malware with Frida and Geetra. So Frida help us to in the dynamic process of the analysis. Let's suppose we are having an application and we are not able to understand what it's actually doing, and we want to hook into some particular file. There might be some packages out there we can use, or we can write our custom scripts. For example, if you look, this is the malware that I want to analyze, and This is its manifest file and the main activity. In the main activity, we can see uh, it's really difficult to understand what's going on or what is happening, but we want to hook into some particular, let's suppose this wing gap part we want to hook. So over here, we'll install our application and start our Frida server. And if we want to write our custom code, we can refer to Frida documentations. It is having a section of JavaScript's API, and we can go through various. I just want to hook it, so I am using this function. And now we need to write a custom code. I just want to hook and display some message that I am able to hook into this function. So I'll write a, these all information is available on the website. If you'll refer the documentation, it would be easy for you. Everything is running fine. And I am launching that application using the Frida hooking. So you can see over here, I have got the information I want to write. Like I have printed inventor was here and it's getting printed inventor was here. Now we are having Ghidra. What is Ghidra? It is a reverse engineering tool set. Let's suppose some malware author have written their complete code in native code. So using this JDAX or any other tool won't be helpful for us, as those code are in assembly language. So we use tool like Ghidra. We'll just take an application. We can see there's a SO file. We can use either APK tool to extract that or just rename the application to .zip and we'd be able to extract all its content. We'll load that libvg.so in our Ghidra. And we are able to analyze each and every code. All those functions should be defined under function Java and all the function that is there. We can see Java s.ni.iz that is present in our system. And if we'll look closely on the right side, we are having a decompiled Java for the binaries we were having there. So we can, it's really handy and many times we need to use to understand what the malware author is actually trying to do with our code. If we have talked about dynamic loading. If application is dynamically loading a DEX file in the memory, we can use something like Medusa or Frida dump to get those all uh, dynamically loaded code. So let's start with analyzing some sample. So the very first one is a ransomware sample. So if we'll install that application in our system, we'll get something like this. This was a POC ransomware, so it's not that complicated. But further, there are various different kind of ransomware, really complicated. And it what a ransomware does, it create a screen and it will lock each and every functionality of our device. We won't be able to access our uh, camera, contents, SMS, or anything. So this is a ransomware. Let's look into a source code of that same ransomware and how it works. So this is the Android.manifest file which defines the whole application. We can see the application is taking these permissions like write external storage, read external storage, find location, wake up, unlock. On the second line, we can observe that it is taking system alert window. It means that this application is having permission to create alert window over our in our system over the view. And further, we can also notice that it is having an intent filter that is set on boot complete and quick boot power on. It means that the application would be aware that the boot process is completed. If we look into the main activity, in the main activity, it's trying to or it is starting a service called my service. When this main application is on created, the application is set on create and it is calling this service. So if we look the my service file, we can see what it is doing. Over there, it is having the permission of window manager. With that, it would be able to create a screen or pop up over everything. And this is the part where they are creating that red pop up we just saw. And this is the view and everything is defined over here. And on click listener is there. So when a user click, it will start this on click listener and check. This is the key. So in ransomware, what happen? Attackers with who's the owner of the ransomware, if you will pay them money, they'll send you a key, and that key you have to enter, and this application will check if that key is correct. It will unlock your system and you would be able to use your device. Ideally, it might just break your phone or do something else, and or maybe even if you have paid, it might not work. But here, this is the key value that is getting checked if that application is working or not, like if you have provided the correct key or not. In this way, a ransomware work. This was a very basic example of a ransomware. These can get really sophisticated to using RSA or SHA keys and various other kind of evasion techniques. Ransomware or Trojan are really common in the market, and we can find various different families of those malware. One interesting malware found last year by Lucas from ESST was Bad Bazaar. It was actually uploaded to Play Store and was having over 500K downloads. It was called Telegram Pro and Signal Plus Messenger. What it does was, as I was talking about the WhatsApp application, Signal is also having feature to connect your mobile application with your desktop application. So in this case, an user is installed Signal Plus on their phone, and attacker or the Signal Plus will be having a desktop in their system, and our device will be connected to their system, and they would be able to look in all our chats and files we share and each and everything. If we look for a demo, and for this credit goes to Lucas, there is no linked device, and when he get back to the main screen, you can see a signal connection is being established between our smartphone and the desktop. And again, if we'll go ahead and check the link device, we can see an attacker device is connected. Although we would be able to unlink it, but the point is we would never know that if our application is being connected with another attacker's desktop or anything. So let's go ahead and look into the code, how this is actually happening. This is the Android.manifest. So what does in this malware attacker have done? They just get the whole Signal source code. As we know, Signal is open source. They just get the complete source code and modify that to gain some kind of permission or just spy on us. This is the manifest file, and we can see our main activity over here in org through crime secure SMS main activity. If we'll go ahead and look into the main activity, this is our main activity. This is what will executed when we launch our application. Here we can see on create is defined and everything. Further, we can notice on resume. Uh, we have noticed that the device was not directly connecting with the attacker's desktop. It was connected when we resume our application or resume our main activity. So what it does is it's create a new function. It is starting a thread using runnable, and runnable threads will run in the background. Like a normal user would not be able to see until unless they are logging it or monitoring what it's going on. And this function will be working in the background. We can just a minute. So this function was being called. In this, it is our device info utils are being called. If we look into this, what is our device info? We can see each and every information like IMEI, number, MAC, and everything is being recorded in JSON put object. And from there, the application get all those values. And after that, get login info is being called. If we look into the get logging info, it is just putting our IMEI number, and it handles our the whole login part. Like when we log into our desktop environment, and in our get login, we can see get application context and client login information. And there's an function defined called get URI to login. Here is where the URI or the IMEI, or when we scan our QR code, there are some data that is getting downloaded from the, or you can notice that they are getting it from Signal Plus or API QR code, and it is combining with our IMEI and creating a request to login. This is the handler. When that handler is being called, a new handler will be started. It will start this activity, which will with all the information of QR code and everything. New device, active device on link connection will be created. This on link function is used to connect our desktop with our smartphone with our desktop, or our account with the desktop application. If we'll go into our device info util, and move to on link function, we can observe that our uh, device is being connected with the attacker's device. Like as we are having attacker's QR code value, and the function is getting start. If you will notice down there, there is a on link function, and above there is on link h function. What is the difference over here? If you'll go ahead and download the original source code of the Signal Plus app to link that our desktop with our account, they are using on link function. Now what this attacker or malware author have done, they have just used the same function and created another function that is being called to connect with our device. They are exploiting the feature to connect to our desktop application, and this is the reason they were able to upload it to Play Store, as there is nothing malicious. This is the intended activity of the application. Just there, rather than connecting with our desktop application, our account is getting connected with attacker's account. As you can see, the on link function is defined over here. So these are the two analysis of malwares. Moving to the final part, conclusion. Now we have gone through various components, architecture, and what is the life cycle of an Android application, how these malwares can attack that and use for their own benefits, and exploit our various components, permissions, maybe loading part. Now if we'll talk about for a normal human being which is not very tech savvy, how they can figure out that if they have installed a malware. As we can see, there are various malwares getting uploaded to Play Store with various evasion techniques. We should be noting the permission that application is looking for. Let's suppose a note taking application is asking for accessibility permission or camera permissions. We should be suspicious why a note keeping application need accessibility or camera permissions. Or let's suppose you have installed an application, everything is going good, but suddenly you realize that your whole mobile application have started running very slow and laggy or overheating. Or you can observe, if you have a network capturing tool, you can like proxy pin, you can go ahead and see network activity that is happening at night. These are some indication that there is or there might be some malware in your applications. So that's all from my side. Any questions?
Guys, the session is open for Q&A. If you have any questions, put it in the chat box. Amit will address your questions one after the other. And Amit, there are a few questions in the chat box. You can.
Okay, yeah, I am able to see that. Okay. So is there walkthrough for Bug Bazaar? Actually, we have that, but we haven't released that. You need to go ahead and try it on yourself. Tools which are free to detect any Android malwares if can be detected. You can use Virus Total or Kudu's. These are some scanners that you can go ahead and try. If that malware have already been detected, it will flag it as malware. Yes, malwares can read memory of Android phones if they are having read and write permissions. Programming language to start in malware. If you are talking about crafting a malware, it's completely up to you. You can write in Java, Kotlin, or maybe you can just use React Native. There's a malware called Terracotta that was using React Native to develop. Or if you are talking about analysis, you should just get started with normal Java, as at the end of the day everything is getting compiled into Java. For that you can refer to developers.android.com. uh, Link for proxy pin. Yes, sure. If you'll just simply search proxy pin on GitHub, you'll get that. But just a minute, I'll put that. It's just not proxy pin. There are various. Okay. Is there any samples to test? Yeah, you can start with various samples. You can refer to Malware Bazaar. You will get samples over there, or you can even connect with me over LinkedIn. I'll share all the malwares to get started with. Here, you can connect with me over here. Free resources to learn Android VAPT. You can refer to Payatu's blog. We have detailed blog to learn VAPT about Android. Or if you want to learn about React Native testing, there's an ebook by our team member Vedant. You can refer to that. Or if you want to learn how to write custom code in Frida, or how Frida overall works, you can refer to our latest release on Frida. What are the common steps I take? So if you are suspecting there's a malware, try to delete that first, very first, and then you can put it some time to notice if you are still facing the same issues, or is there anything that should not be happening but still happening. And the last option is formatting, actually. For which link you are talking about? The books and blogs. Here, you can visit to payatu.com. There's a resource section. There you can find all those ebooks and blogs. So if you are talking about Trojan, if you are using a non-rooted with Play Protect enable phone, most of the Trojans or malwares won't be able to install if you are having Android 13 or the latest Android. Version by version, the whole Android ecosystem is getting safer in detecting malware, and you should be safe. Even if you want to just go ahead and check. There are various different kind of tools that you can refer, but for the static part, as I was talking, you can refer to MOBSF. it will give you a static overview what the application is doing. Then you can refer to Frida. It will give you the whole source code of the application. You can, and then it's up to you. You have to go through line by line and analyze what those code are doing and how that malware is working. And for the dynamic part, you can install any emulator, or if you have a physical device, that would be great. And then you can use burp to intercept each and every request sent from your device. If you want to dump memory, you can use Medusa, or I won't refer to any course right now. You can start with Android penetration testing. Once you are having a good idea of how to reverse an application and understand how the application is working, you will be able to understand malwares. There is normal Android apps and malwares are not very different. It's just the intent, how they are using those features provided to us. I'll go with a physical device if you can afford that. Many times we'll face emulators are getting laggy or they are not responding, and many malware are having emulator detection. If then you again have to bypass those emulator detection, maybe by patching the application, or using Frida to bypass those detection. Also throw light on uses of Medusa tool for memory dump. Would you? Okay. If you want, let me reshare my screen and I'll show you a demo of Medusa, how it's done. Let me know once my screen is visible. I hope it's visible, correct?
It's visible.
Okay. So if we are using Medusa, initially you just need to visit to GitHub and download Medusa from there. It will load. As you can see over here, it lists out all the available devices, all the available device. Then you have to choose which device you want, and then all those properties of your smartphone. I was using a physical device from Samsung. All these information are being displayed, and various application those are installed in our system. Further, you can use search command to look for all the modules. So Medusa actually is running using Frida only. For using this, you need to run the Frida server on your system, and then you would be able to use Medusa modules to do this. You can consider them as similar to Frida scripts, but rather than you loading Frida and everything, this is a package tool that we can use. Uh, let's suppose we want to dump DAX from our memory. So we can use this module, memory dump DAX. Just a minute, it's not playing. Hmm. So we will write use module memory dump and then compile. The script will be compiled, and we can use a list module to list all the processes in our system. And let's suppose I was using for tmux. So tmux was defined at 335. I will go ahead and run slash hyphen n and 335. It will dump our text file. Location is over here and application information is. But let's suppose you are you having a malware which is using dynamic text loading that you have verified or viewed in the JDAX. There's an option in JDAX for searching. You can just go ahead and search for DEX. You will get all the uses of that word in the application, and then you can use the same method to dump your DEX files. So this is how we use Medusa. A demo video of Ghidra tool uses. You need to have the SO file. You'll just load that. It's simple. If you can connect with me over LinkedIn, I'll share this same file with you, which I have generated the POC. Or if you want, I can present it again. Okay, the basics. It's visible, I believe. Aparna, it's visible.
It's visible.
Okay. So we can see this was the malware sample I was using, and many of these function are related to the native code. We can see there's a libvg.so over here. What we need to do is we want that SO file from our APK. Now there are two methods, a clean one and a dirty one. You can use APK tool to decompile the APK and get that SO file, or the dirty one, you can just rename it to zip file and extract it. You'll get all those information. See, I am doing the same. I'm just copying the application and renaming it as zip. Now, once you have got the lib.so, we can start working on the Ghidra. You can download Ghidra it from GitHub, and then you need to create a project file. Then you just need to select your malware or the sample you want to analyze. I mean the SO file over here. Once your sample is there, the tool will be launched. Okay. So in the center, we are having the whole assembly code. In when we are talking about the native code, it's basically assembly, and it would be really hard for normal human to read. But if you are passionate about assembly, then go ahead. You can enjoy analyzing the whole assembly. Okay. Now on the very left, we can have a symbol tree, and under that in function Java, each and every function that is written in our application are there. For example, you can see function Java. You can notice java.j.kc.gaz or even s.ni.jz is defined there. And if I look into my JDAX or the file that I have decompiled, you can see under the package S there's a public static native object called iz. How this Ghidra work is it lists those function in complete way, like it provide a complete path where they belong. Okay, so once we want to analyze this part of the code, if we'll click on that, on the very right side, we can see we are having a decompiled Java, which is comparatively very easy to understand. And from there, we can start observing what and how the malicious application is doing. So this was the basics of Ghidra. If you want to explore more, I'll suggest just go ahead and download malwares and start. Can you do for application in Play Store or an application which is an open source? Is there any links to understand these topics? Again, the whole video will be uploaded to YouTube. You can refer it anytime you want. Else, a simple Google search will answer your question. Or if still you face problem, you can connect with me over LinkedIn and you can have your solution. Yes, in Malware Bazaar, there are various APK files which are detected as malware. People upload it over there for researchers to download it and observe the behavior and how the malwares were getting installed or how they were working.
That's it. Thank you,
Thank you,
Amit,
everyone.
for a great session. Thank you for such being wonderful participants. Have a great weekend, everyone.